So on a calculator, you can actually find the value of a derivative, but only at a specific point. And you can do this using a derivative in the math menu or sketching it in the graph. And I'm going to show you how to do that. So what the thing is called is inderiv, approximating the derivative, and that's why it needs to be given a certain value, because it cannot fully find the derivative. It can only approximate at individual values. Okay, so this problem is saying if f of x equals x cubed plus 3 to the x, find the derivative at x equals 2. Now, your newer calculators, which many of you have, you will not have to plug it in this somewhat strange way. But I want you to see the strange way to plug it in, just in case you do have an older operating system. So in an older operating system, you would include the function and then put a comma, include the variable with respect to which you are deriving the function, and then include the value for which you want the calculator to evaluate the derivative. So using math and inderiv is the 8th option. Here in this newer version, you have a nice setup. So we just derive with respect to x. I'll just use the variable button. And then our function goes in here. So x cubed plus 3 to the x, and we want to evaluate that derivative at x equals 2. Enter. Yay, we got 21.8875. 21.8875. In the AP exam, you could leave it like this, or you can round or truncate, but no less than 3 decimal places. So this could equal 21.887, where I just literally cut off the 5, or this could be 21.888, where I round the 7 up because after it comes a 5. If g of x is equal to the natural log of x squared minus 3, then they want us to find g prime of 2, and they want us to find g prime of 4, and they want us to sketch g prime of x. So instead of having to plug this into the inderiv multiple times, plus I want to know basically what this graph looks like so that I can try to sketch this graph. So I'm going to start off by plugging that in to y1. Okay, now I can just refer to it when I use inderiv. So second quit will get me back to my home screen, and then I'll go to math and 8 to select finding the derivative, and we're finding the derivative with respect to x of y1. So you go alpha trace to refer back to y1, and we want to know first of all when x is 2, enter. All right, when the derivative at 2 seems to be something pretty close to 4. Now, if the calculator had given us 4 as our answer, we would not need to write 4.000 to make sure that you had 3 decimal places. But after these zeros, there is still stuff happening. So because it does not continue with zeros in perpetuity, I decided to write 4.000. But if you're ever confused about the rounding and truncating, you literally don't have to cut off any of the numbers. You just leave it as the calculator gives it to you. Okay, so g prime of 4. Doing the same thing, math 8, the derivative with respect to x of y1, so alpha trace, enter, and we're plugging in 4 this time. That is 0.61538. You could leave it as that. I already cut off some of the decimal points from the calculator. Or 615, and that is rounded and truncated. That's the same. Okay, so these would be acceptable answers, but so would these. Okay, so either one. And then we want to graph g prime of x. So we will go back to y equals, and again, the calculator cannot evaluate the derivative entirely, okay, but it can graph. So we're going to do math in deriv, the derivative with respect to x of y1, so alpha trace, enter. When x is equal to, well, I want to know for all x's. So even though you can't do this in the home screen, you can do it graphically and just plug in the variable x. Now we will graph it. The graph of the derivative is here in red. And there I have a little sketch of it. Our last one is to evaluate f prime of 0 when f of x is equal to absolute value x. Remember, second mode will get you back to the home screen every time. So we're going to find the derivative with respect to x of absolute value. Remember, that's math. Go to num abs. That's the first one. So you can press enter or 1. And then we're referring to absolute value x. And we want to know when x is equal to 0. Okay, so the derivative is 0. Wait, is it though? I actually know what this graph looks like. Absolute value x looks like this. So there's a problem at 0. At x equals 0, you have a sharp turn. The calculator is unable to recognize the sharp turns. That is one of the issues with the programming of the TI. So in this case, even though this function is not differentiable at x equals 0, the calculator does make a mistake and give you a value. What is the value at x equals 0 of the derivative? Well, when it's not differentiable at that value, then your answer would be undefined. That's another reason why it's so important for us to have a picture of these graphs in our head before we even graph them, so that we can truly check ourselves and check the calculator and see, okay, is this giving me the right value? Okay, that would be when you're checking your work. On the test, on the AP test, they wouldn't give you something that the calculator would purposely mess up on.